Hello and welcome to this webinar around why Azure is better for SaaS than on-premises. My name is Symon Thurlow. I'm from Parallo. I'll talk more about Parallo in just a second. So a quick run through the agenda. I'll quickly go over who Parallo are. A very brief Azure 101. Most of you will know what Azure is, otherwise you probably wouldn't be here. Then I'll go through in detail around Azure versus on-prem and our experiences with it firsthand, and then we're open to a Q&A session. So who are Parallo? We were founded in 2007. We started out as a VMware professional services firm. We moved into managed services in about 2011, and since 2014, which is most relevant, we've been highly focused on managed services and professional services for Microsoft Azure. We have also sort of narrowed down to focusing on the ISV segment and moving apps to Azure. So rather than the IaaS side of it, of course we are quite familiar with IaaS because quite a few applications require VMs to run and so on, but we're certainly quite focused on the ISV side of it. So we're a Gold Microsoft partner in the cloud platform competency. We are a tier 1 direct CSP. We're a fast track Azure partner as well. So very focused on the Azure platform. And we're a sole Azure cloud platform specialist. We don't do AWS or GCP, although we have some familiarity with those. We have designed, built and run platforms on Azure for our ISV customers in about 17 of the 54 Azure regions so far, all from New Zealand. And many of our customers run business critical services, so we support them 24/7. Once again, my name is Symon. In the Q&A session, we'll be joined by James Brookbanks, who is our Azure practice lead, and Blair Corbett, who is the Azure service manager. So James is fundamentally accountable for the technical side of our Azure services, and Blair manages the operational and customer side of it. So they are both very good people to ask questions of, should you have any. So moving right along. Quick Azure 101. So straight off the Microsoft website, what is Azure? It is obviously a public cloud platform, has an enormous and ever-growing service catalog of features and capabilities that ISVs or app owners can leverage to get their product to market. It's very flexible. We've found it to have matured quite quickly from the early days, where perhaps it was a little bit bumpy as Microsoft moved from a product company to a service company, but there is, in our opinion, certainly no deficit between AWS and Azure anymore. In fact, as per the stats that are publicly available, Azure is rapidly catching up in terms of market share, and in fact, has far more market share than AWS. So why would you actually choose Azure? Again, straight off the Microsoft website, and the link is at the bottom of this page, so you can go and have a look yourself. One of the very strong features of Azure is the Compliance Center, and the fact that there are an enormous amount of standards and so on that are already complied with. So that's a very enabling point for ISVs as they go through the maturity cycle, and often where they might get questions from prospects in terms of, well, do you comply with HIPAA? Do you comply with this, that, and the next thing? You can quickly divert those questions across to the Compliance Center and give your prospects a degree of comfort that perhaps if your code base isn't compliant, then certainly the infrastructure that it's running on is. And there is an enormous amount of ongoing work that happens in that space. Azure is truly global, more regions than any other provider, 54 at the moment, and it's sort of growing all the time. There was yes, that's quite incredible, really. 90% of the sort of biggest 500 companies in the US trust their business around Microsoft, so that's a pretty good rubber stamp of approval, really. It is evolving quickly. We've found, certainly previously, when we considered, should we be focused on AWS as well as Azure moves so quick. It's pretty much every week there is a new feature that comes out, that it's really not possible, we feel, to be specialists in more than one cloud platform, and be really deep, unless you're a very enormous organization. So due to that, what we find is that quite often there are new features coming where our existing customers can leverage those features to either improve their security posture, reduce their cost, improve performance, improve the customer experience. It really is astounding. And I've coined this term of Microsoft having the ecosystem from code to customer. So really what that's saying is that there is a very good built-in synergy. Excuse me, between excuse me there for a second, just on the back end of a cold. The code to customer comment is that there is a really cohesive story between the developer on his laptop or her laptop right through to getting that app to the customer. Quite cohesive. If you're there's a degree of familiarity the whole way through. It's quite a strong ecosystem. So let's get into the meat of it. So Azure versus on-prem. I've broken that down into a bunch of points, and the first four are the key points that Parallo as a managed service provider focuses on. So security, performance, availability, and cost, somewhat cheesily coined as the pillars of Parallo. They are the four pillars that we believe you must be across in order to run an application well. Everything that you do is across those four pillars: reactive, proactive, innovation, continuous improvement, all that sort of stuff. And on top of that, we'll go into deployment, troubleshooting, the user experience, and speed to market, and see if we can weave in direct personal experiences as we go through. So if we hit security to start off with, very topical for people who are putting their app and information in the cloud. And perhaps as many of you know, security is a process. It's not really a solution. It is a continuous thing that never ceases and stops. There's always new threats and vulnerabilities coming out. Catering for security on premises is very expensive, very costly. It's generally a pretty fixed configuration. If there's a new capability that comes out to improve your security posture, it's business case, board approval, or finance committee approval. Really painful and slow to bring anything new in. Of course, these things are typically hardware appliances. Perhaps some are software subscriptions, but many are hardware. They age. They become less relevant over time. You have to go through replacement and forklift upgrades and cycles and so on. Security requires a pretty high skill level, and through personal experience, it's quite difficult to get high quality security people who will stay with you. As soon as security people grow in competency, security specialist services businesses will snap those people up. And there's typically a pretty broad range of capability required. So trying to maintain all that within your organization, unless you've got a very large organization, and many ISVs are not large, then that's pretty impractical. And security generally is somewhat reactive in terms of dealing with things as they come along. Microsoft have moved forward in leaps and bounds in terms of the degree of significance they give security. Now, that's a bit of a no-brainer. If you're a public cloud platform, you don't want to be known as the least secure, but Microsoft have really moved forward. So there is access to an enormous volume of security-related features, advice, all sorts of stuff, which is really a bit too deep to get into in detail in the session. So I'll really just skim over the top. But as an example, a lot of the security features like DDoS, IDS, all sorts of other stuff are available at very low cost, sort of per web app or per object within Azure. You can deploy them with a click of a mouse rather than a 3-month, CapEx purchase cycle. They remain continuously relevant. Microsoft are adapting and updating these things all the time. There's no forklift upgrades anymore or replacements. Arguably, there's a lower skill required because a lot of the IP around what you need to care about is built into Azure itself. It's highly flexible and proactive, so obviously you can turn these things on and off. You can apply them to this and not that, all that sort of thing. There's very good policy management to define security policy across objects and get alerted or warned when, or even briefed when policies are breached. I've covered the continuous innovation part of it. It's just amazing the cadence at which new features come out. There's very broad coverage, so within Azure, a security lens is put across everything. So rather than just having an IDS or a firewall or whatever else, there is a security lens across most objects within Azure, and quite a lot of it's automated or automatable, if that's a word, in terms of being able to put these features in place across your estate. And I mentioned the Compliance Center before. That really is something, if you ever come across those requests from your customers, go and have a look at Compliance Center. There is an enormous wealth of information in there, and it's extremely valuable. I've put a link on the bottom of this page to, sorry, I'll go back there, to where you can find out more information in detail. So just one example of one of the features, security features within Azure, something that our managed services guys use daily, is the Security Center. So Security Center is quite deep. There's a lot to it. Again, another link at the bottom of the page there to go and review for yourself. But this is sort of a dashboard view of your security posture within Azure for the objects that you have it across. So this is a very good place for for a point-in-time glimpse at, hey, what is my security posture like? Are there issues that I really need to deal with straight away? Are there things that I perhaps can live with? Am I getting brute forced? Are there all sorts of things? So common attacks and so on. This is really immensely valuable. If you are running anything in Azure, you must have Security Center enabled. There are different tiers of capability, of course, but operationalizing Security Center would be our almost number one recommendation, because the worst thing you can do is get owned. So just as an example of some of the features that are relevant immediately to our customers, SQL Azure auditing. So this can be pretty intensive, so you need to choose what you apply it to and how long you keep the records for. But this is very detailed: who did what, who deleted that table, who, all that sort of audit trail of activity, which is very important when you're following a unexpected behavior, or someone does something which is suboptimal, and you need an audit trail of how that happened. SQL Azure Threat Detection, so sort of IDS for SQL. This is very valuable. in one of our customers, they're a truly global company, have people all over the place. We have a mechanism for them to open up access for some of the people to gain access to SQL from different locations, and even though we have a rigid process in place to enable that, we'll still get alerted that someone has accessed the database from an unusual location. Just as one example of the sort of insights that are almost built into Azure. It's wonderful. There are application gateways, so web application firewalls, looking for malformed requests or SQL injection, or all that sort of stuff. The OS top 10 as a tick box, which will then be monitoring your web apps for red and blue teaming. So this is where there is a team of highly capable engineers who are tasked with breaking into something. So, attacking, figuring out a vulnerability, getting into and compromising an app. And there's a blue team who are there to prevent that from happening. It's a war games, they're calling it. It's really enthralling. I put a link there in the bottom to the PDF which talks about this in detail. And this is the sort of proactive activity that Microsoft take to actually go and test and make sure that what they're doing is secure and stable. It's really it is quite comforting to know that this degree of analysis is underway. Excuse me. There's built-in DDoS protection, built-in IDS, so the whole advanced threat analytics thing, and there's a whole lot more. So you can see all this on those previous links and go into detail. I'm really just wanting to illustrate the picture that some of the common things about SQL getting hacked, or applications getting vulnerabilities thrown at them, DDoS attacks, all those things are sort of catered for out of the box with a few mouse clicks. It's really quite amazing. So in terms of performance, obviously for on-premises, building infrastructure on-prem is capital intensive. You end up with a rigid config. You've sort of got to cater for your peaks, so it's highly wasteful typically. It's really slow to provision anything new. It's really slow to expand anything, especially if you've made a mistake and there's no budget. It all ages out, and you've got to replace it every 3 to 5 years. And there's a whole lot of BAU to go on in terms of keeping the lights on. I'm probably preaching to the converted, but that's obvious. That's how it's always been until the last 5 years or so. But those days are certainly over if you're an ISV. So the beauty of Azure, obviously, it's OpEx. It's very flexible and caters for bugs, and I'll talk more about what I mean by that in the next couple of slides, in a couple of slides' time rather. It's rapid and automated scaling is available. So if you have a peaky workload, then, and maybe it's once a month, you have a business process which slams your database or has a whole lot of people wanting to do stuff all at once, you can just preempt that, scale out, no user experience hit, and scale it back when you're finished, rather than on-prem having to design and build for that peak that happens once a month, and the rest of the time you're paying a whole lot of licensing fees for all the extra hosts you need and blah blah blah. In theory, there's unlimited resources. I put an asterisk next to that. That's actually not entirely true, because everything is finite, but certainly in terms of most ISVs, their resources are unlimited. I know there are some ISVs out there, and we work with some who really push the boundaries. So it's not an answer for everyone, but for 99.9% it is. Obviously, there's no replacement cycles. From time to time, there'll be some SKUs that get grandfathered, like VMs and so on, as new ones come out. But other than that, it's really nothing like having to forklift upgrade hardware. And there's significantly reduced BAU. It doesn't go away. You still have to manage what's in Azure, but you don't have to manage all of the non-differentiating aspects, such as hardware and so on. So some examples of performance. Most of the objects in Azure scale. So you might start off with 100 users and have a small size web app, or whatever else. And then as your business grows, Azure can scale with it without having to go and buy more hardware and try and keep up with demand. You can scale it within seconds in most cases. There are automated actions, many out of the box, some that you need to code for, that can cater for spikes. So should you have a sudden demand because, I don't know, something you got goes viral, or you've got, I don't know, presence at a conference, and all of a sudden you get a whole bunch of people wanting to look at what you do, all those things can be handled. Once again, it's not the panacea for all sudden demands. There are some requirements on code. We've seen some instances where apps are built to engage with end users in a certain way, and when they get to a sort of unexpected scale point, perhaps that's not the best way. But still, the automated capability and the to scale is quite astounding. Legacy can sometimes be an issue, but really that's for old chatty apps. Any modern app, should be designed to work around latency, and in most cases, not all, but there's an Azure region pretty close to most people. Perhaps Africa is just starting to get there, and apps typically run faster on Azure. And this is a comment really that there is such a immediate scale opportunity for any load that as soon as a suboptimal sort of configuration is detected, if you're running on Azure, you can scale it really quickly. If you're running on-prem, you've got time to have to go and scale and maybe request new VMs or do whatever you need to do. So that's a bit of a general statement, but one that we see to be true. So in terms of cost availability, got a really good example, which is a real-world example, which I'll talk through in a sec. But to provide high availability and DR on premises is very expensive. If you think SQL, you're thinking enterprise SQL licensing, which in itself is quite a large cost. All of the hardware required and so on to have things highly available. It's pretty difficult and expensive. DR is time consuming and difficult and quite expensive. Think second data center, comms, second, duplicated hardware, it costs you the same cost as prod plus, because now you have to manage replication, you have to make sure it's working, all that sort of thing. If you made the assumption that your old prod hardware will do for DR, well, you've made it no longer prod hardware for a reason. So, if you ever actually have to turn it on, it's typically not a pleasant experience. And there's quite a lot of BAU around management, around making sure that these HA and DR solutions work on-prem. In Azure, once again, it's OpEx only. It's relatively low cost. So the actual cost of establishing it is orders of magnitude lower, but also the actual ability to do it and the speed at which you can do it is quite astounding. There's quite a lot of out-of-the-box capability to enable HA and DR. So as an example, every SQL Azure database has, I think it's 3 in-zone copies. Now you can actually read from some of those, as well as having regional replication out of the box, inter-region, I should say. Availability groups are available in for VMs, etc., where if you put a couple of VMs into a availability group, then you can be assured that they're not going to be in the same rack, which means obviously if a rack dies, you're still going to carry on. All of these things are very quick to establish, most of them out of the box, and therefore the whole need to feed and water is significantly diminished, because you're not managing all of this multi-DR or multi-cluster infrastructure to provide this level of outcome. So the example around regional DR, so imagine that you have a requirement to replicate your data to another city and provide very quick, like say sub 5 minute RTO to recover to your second region. So these are all the things. I won't talk through all of them, but these are just some of the steps that you go through. You'd have to do all your design work, which arguably you have to do in the cloud anyway. But then you need to do your component selection, which will have hardware components, software components. You probably want to pock some of those up and try them out. Then you got to negotiate. You need to find another data center somewhere else. If you want to be completely confident that it'll work, you're probably going to go there and have a look at it. So someone needs to travel, negotiate those commercials. You need to find a network provider that will connect the two DCs, and inter-country comms are really expensive if you want any sort of SLA. So there's another commercial negotiation there. Then once you're pretty well sorted and you know what you're going to do, you've got to place orders for hardware and wait for a long time for all that hardware to show up. You got to build it, you got to all that sort of stuff. You got to ship it to your DC and go through the import hurdles of doing that. You got to rack and stack it in a remote location. Got to configure it and install all the bits and pieces. Test it, get it all running. So as you can imagine, that'll easily consume 3 months from we need to do it to it is now working, if not longer. It's really quite a major project. Flick to the cloud, and this is actually what happened. So one of our customers was in the Southeast Asia, so Singapore region. Bunch of cloud services, SQL Azure databases, and so on. Big customer needed to have pretty quick DR capability. So after identifying that need, doing a high-level design, which was quite quick, even the detailed design was quite quick, because this is, we're going to use those objects, we're going to configure them like this. It took less than a day from having the detailed design fleshed out to actually getting it up and running. And that's because a lot of the stuff is just tick boxes and configuration, or PowerShell and so on. This was replicating a database to another city, establishing duplicate cloud services to provide the web front end. I don't think we even put Traffic Manager in front of it, although we probably should have, which would have enabled the automatic failover, and then testing that failover and fail back. So it's really quick and easy to do this in Azure because all of the components are there. It's quite straightforward to figure out how you're going to do it and then go ahead and configure. There's none of that the physical aspect of trying to pull it together. So it's really quite astounding. And until you've actually gone through that process and seen it happen, it's really, I know it sounds great, but it's amazing. So in terms of cost, cost is when comparing IaaS cost from on-prem to Azure, I guess depends which lens you put on it. Perhaps on-premise could be cheaper. It really depends on what factors you put into it. Arguably not if you're using all of the scheduled shutdown and other capabilities of Azure. But really, this is just reminding everyone, this is the ISV lens that we're looking at it through. So to have a environment on premises that even comes close to what you get in Azure, it's extremely expensive. We've talked through the HA and DR costs. We've talked through security costs. All those things really stack up. If you want to expand capability on-prem, you have a really big increment of scale. It's either a complete server, like physical server, or a whole nother storage array, or another, I don't know, IDS jump from X bandwidth to Y bandwidth and so on. It's very costly to run. You need a bunch of highly skilled people or a bunch of outsource agreements in order to manage it, and you've got to design and build the peaks, which is very inefficient. When it comes to Azure, again, it's OpEx only, which keeps it simple. Interestingly, one of our customers told us that when they need to expand storage on premises, that process actually touches 7 parts of their business: legal, accounting, infrastructure, blah blah blah. It's really quite onerous. So in Azure, however, it's OpEx only, so it's relatively low cost. There are very small scale increments. So if your load increases, then you can just scale up some of the objects within Azure at dollars per month scale rather than tens of thousands in one hit. everything is capable of being automated. It's either scale within the Azure portal itself, or as we've done, write some pretty attractive automation processes to detect thresholds and so on, and manage automation and manage scale. This means that the user experience is typically better because you're either preempting or certainly moving quickly when something does hit that's impacting performance. The scope of security we've talked about is just unbelievably broad. Trying to have all of the security features available to an on-premises environment would just be impractical. Pardon me. So the cost of achieving the outcome that Azure provides is really prohibitive on premises. And we've sort of gone through those examples, talked about DR and how it'd be hundreds of thousands up front to build out the on-premises, whereas it's hundreds to thousands per month, to have all that at your fingertips on Azure. So in terms of deployment, we have first-hand experience of a customer who has both an on-premises deployment model and a multi-tenant SaaS model. The on-premises model is very cumbersome. The artifacts to build to enable on-premises, not that much of a hurdle, but really what we find most often is that because the deployment of the on-premises model is manual, and the people doing it, if you have the same person who's done it forever and that person is highly confident, then it's not that much of a problem. But often that's not the case. The degree of complexity for an on-premises deployment can be high, whereas it's quite easy to have that separation of zones and whatever else in Azure. So we've found that the deployment of on-premises upgrades and so on is problematic. Quite often it's people related, not following the instructions. Here's the 20 pages of verbatim instructions, please follow them. And some people don't do that. Typically you'll have to have multiple environments on premises in order to do a run through of the upgrade and then do it in prod and so on. It's really just quite old school and problematic, as opposed to Azure, where the build and deploy process is pretty much possible to be completely automated. So in this instance, the specific example on premise, here's a bunch of binaries. Here's a blob storage location. Go and retrieve and follow this 20-page document that hopefully we've updated to factor in any latest changes. Go ahead and give us a call when you've forgotten to do something. That's a bit cynical, but when something doesn't work, as opposed to Azure, where it's okay, build and deploy. Off it goes, depending on the model you're using. In this instance, it was cloud services. So push into the cloud service, spin it up in staging slots, smoke test it, make sure it's working fine. Do a virtual IP swap, boom, you're in production. If it doesn't work, flick it back. It's just so quick and easy. It's automated, so it's entirely repeatable. Every time it's done the same way. That really reduces your troubleshooting time if there are any issues, and ensures a really rapid sort of upgrade process. In terms of troubleshooting, when it's on premises, many systems are required to provide decent visibility into what's going on when you have a problem. You really need third-party APM skills, which not everyone has. You need Splunk or some other, Elk or something else to capture all of your data from every component to actually have a consolidated view of what's going on. You need good infrastructure management capability. You need good infrastructure. When you're running on-prem, you might be sharing that platform with something else. So, the whole noisy neighbor syndrome, someone's smoking the capacity, so your app gets starved. And you really need a really rapid and participatory network team. And depending on, what the culture of your business is like, network change is bad. So, it can be troublesome to get prompt participation. When running your app on Azure, Azure has this highly cohesive and consolidated ecosystem of management and alerting, so you can quickly chase down where problems are happening. So log analytics is, in our opinion, a compulsory component of Azure to consume. App Insights, again, if you're not using New Relic or something else, App Insights is really growing in capability very rapidly. That'll tell you what's going on within the app. Everything is sort of, cohesive. Coordinated is probably the wrong word, but cohesive. And there's quite a lot of telemetry built into Azure to help you comprehend what's going on. So it can be simpler to troubleshoot issues on Azure. Occasionally there are Azure-related problems that have nothing to do with you or the way you're using it. The Microsoft are reasonably good at making that public. They don't really hide it. By all means, you should have a Slack channel or a Teams channel, I better say that, with the Azure status pumping into it, so that you can keep on top of any issues that happen. But we've found Azure to be, especially with these tools in the last, and there are others as well, of course, such as OMS and so on. But these tools have really matured over the last 12 months or so to the point where they're pretty powerful. So in terms of user experience, and I've sort of touched on this previously, really, when you're on premises, and I guess the easiest way to colour this in is, let's say your dev team has created a new feature, and that feature's impact on the infrastructure capability was unexpected, or there's been a sudden uptake in that feature and it smokes database or CPU or whatever else in the elements of your service. If you need to react to that on premises, that's pretty hard. Sure, you might have a virtual infrastructure or something where you can spin up additional VMs, but you've got to do that. You've got to first understand you've got a problem and then actually do something about it. And depending on what it is that's getting hit, it can be very slow to react, such as maybe you've used all your internet bandwidth up or something. Whereas in Azure, when a performance issue hits, boom, immediate thing you do is scale up. So you've immediately sort of mitigated the end user impacting aspect of it. And now you can go and work through the root cause while your customer isn't suffering. So that is one of the night and day benefits of Azure when running SaaS apps. Because of that, the user experience is far better, and a big scale up, for a few hours isn't going to break the bank. It's when you need to leave it in place for a long time. That's a problem, but still you're mitigating your customer from having a bad experience. So that's really unbeatable. Speed to market. We've sort of talked about that. It takes a very long time to speed anything up on-prem, whereas Azure, you got an idea, hey, let's go try that. Oh, it didn't work, okay, we'll kill it. My cost stops immediately as soon as I've decided I don't want to pursue it anymore. All that sort of stuff is just incredibly beneficial. And I think the other aspects we've sort of talked about. So just to recap, on-prem, CapEx model, painful to buy stuff, slower to provision, cost more to run, it's harder to manage, the user experience is poor, especially when you have some sudden code quality problems and so on. DR is really expensive and complex. You need quite a lot of people and quite a lot of smart people. And these days, smart people get snaffled by other companies pretty quick unless you can keep them happy. So it's a bit of a risk. Whereas in Azure, you can provision stuff immediately. It's a lower cost to run. We've talked about the cohesivity, if that's a word, well, that's a brand actually, the cohesiveness of the management tools. So, provides an overall better user experience to the customer. It's much lower cost for DR, and it's typically more secure unless you've got an enormous budget. Like if you're a big bank or something, perhaps you've got a significant security team, but for most ISVs, Azure will be way more secure than doing it yourself. So thank you very much for suffering through my raspy voice. I hope that what we've talked about has had a chord with you, and now we're open to some Q&A. So thank you.